Welcome to the debate. Right now in Nevada, major tech companies are trying to build these massive artificial intelligence data centers, and they're going to require roughly 3 times the electricity of the entire city of Las Vegas.
Yeah, it's a staggering amount of power.
It really is. And the local utility there has explicitly stated they likely just cannot serve that load without falling back on fossil fuels. So that is a brutal physical reality crashing right into our global clean energy goals.
It is, and it's really the ultimate stress test. I mean, we've spent, 2 decades in this sort of theoretical phase of the energy transition?
Right, lots of sustainability pledges.
Exactly. Pledges, conceptual pathways, spreadsheets, but that era is over. We are now in a highly demanding, unforgiving physical phase.
Spot on. And the central question we are debating today is, well, what actually drives this new phase? Like, what is the primary engine of global decarbonization? Is it the top-down structuring of bankable demand and, regulatory price signals?
Or is it the bottom-up, physical integration of regional industrial systems and heavy infrastructure?
Exactly. To frame this, I think about it kind of like gravity and a hydroelectric dam. From my perspective, clear financial market structures and regulatory cost anchors, they are the gravity. They dictate which way the water wants to flow.
I see where you're going with this.
Right? The capital simply does not move, and the engineers don't start pouring concrete until that fundamental market force is established. My position is that clear financial structures dictate physical progress.
And, my position is that gravity doesn't generate electricity unless someone actually builds the dam. The physical execution, the brutal realities of infrastructure constraints, those are the true determinants of success.
I see why you think that, but let me give you a different perspective. Because if we preemptively assume that physical execution just leads the way on its own, we ignore how industries actually decide the change. Financial engineering is the ultimate catalyst.
Okay. Give me an example.
Well, let's look at the European Union. They just published their first actual carbon border adjustment mechanism, or CBAM certificate price, and they set it at exactly €75.36 per ton of CO2 equivalent for the first quarter of 2026.
Right, that's the mechanism that essentially acts as a border tariff, right, to prevent European companies from just outsourcing their emissions to countries with cheaper, dirtier manufacturing.
Precisely. And it is not just a bureaucratic milestone. It fundamentally changes the game for imported steel, aluminum, cement, chemicals.
Because now there's a hard price attached.
Exactly. By establishing a visible €75 cost anchor, product carbon intensity moves from being this, nice-to-have metric on a corporate sustainability slide to a hard, unavoidable cost variable. The financial penalty creates the physical action. I mean, no one breaks ground on a multi-billion-dollar facility without knowing exactly what the regulatory penalty for inaction will be.
I'm sorry, but I just don't buy that. Let me tell you why. You can have all the regulatory cost anchors and carbon pricing mechanisms in the world, but if the physical constraints of the grid cannot support the transition, those financial signals are effectively screaming into a void.
You're talking about the grid capacity.
Yes. Let's go back to that brutal reality unfolding right now with AI in Nevada. You cannot financially engineer your way out of thermodynamics.
Well, no, but
AI demand growth is arriving far faster than our grids can physically decarbonize. It doesn't actually matter what the carbon price is if the utility physically has to spin up a gas turbine just to keep the servers from crashing. The constraint is the physical layer, not the financial layer.
But see, that massive spike in power demand is exactly why we need centralized demand aggregation and market structuring to clear the path for new energy built. Take the aviation sector, for example. It perfectly illustrates my point about the necessity of financial structuring. Let's look at Infinium's Project Atlas.
Okay, the synthetic fuel project.
Right. They were recently selected under the Sustainable Aviation Buyers Alliance Next Generation SAF procurement, and they've lined up American Airlines to take delivery of their eSAF.
Which is a massive deal, I'll admit. We're talking about a planned project size of roughly 100,000 metric tons per year, with a claimed 95% carbon intensity reduction relative to fossil jet fuel.
Right. And just to clarify for the listeners who might be wondering how ESAF differs from normal biofuel, they are basically doing reverse combustion. They take captured carbon dioxide, combine it with green hydrogen made from renewable energy, and synthesize a drop-in replacement for jet fuel.
It's incredible chemistry.
It is, but here is the kicker. For years, synthetic fuels lacked financeable demand. Developers had the chemistry figured out, they had the lab results, but they could not get the loans from the banks to actually build the plants. So doesn't this prove that aggregating corporate demand into a bankable offtake structure is the actual bottleneck being solved?
I mean,
The physical plant for Project Atlas is only possible because the deal structure aggregated American Airlines' demand into bankable supply.
okay, sure, it proves that offtake agreements are necessary. The bank obviously needs to know someone is going to buy the fuel, but they are not the defining bottleneck of the operational phase we are entering now. If you want to see where the real friction lies, look at the shipping sector. Look at what Shanghai Electric just pulled off at Yangshan Port.
Oh, you mean the biomethanol bunkering operation for the CMA CGM osmium?
Exactly. That is a highly complex physical maneuver, and I don't think people realize just how difficult it is. Having a quote-unquote methanol-ready ship is just a theoretical demand signal.
Right. It just means the engine can theoretically burn it.
Yes, you can have all the corporate commitments you want to ship goods on zero-carbon corridors, but operational bunkering at major, heavily congested global ports is the actual bottleneck.
Because methanol isn't like pumping traditional heavy fuel oil?
Not at all. It's toxic. It is highly flammable in very different ways than diesel. It requires specialized pressurized hoses, double-walled piping, totally different safety parameters, new training for the dock workers. And you have to do all of this while maintaining the incredibly tight turnaround times that international shipping demands.
Yeah, time is money in that industry.
Exactly. If a massive container ship has to sit in port an extra 2 days just to fuel up safely, the entire global supply chain logistics model falls apart. So can you physically store, transport, and transfer these low-carbon fuels reliably? That is an execution problem. China is moving incredibly fast on this execution layer, mastering the physics of the transfer, not just issuing production announcements. That physical execution leverage is what actually defines the fuel market moving forward.
That's an interesting point, though I would frame it differently. While the logistics of bunkering methanol at Yangshan Port are certainly an engineering headache, they are ultimately solvable engineering tasks.
Well, they're not trivial.
No, not trivial, but solvable. And my point is that those tasks only get funded and those engineers only get hired because a financial penalty forces the logistics companies to figure it out. Which brings us right back to the challenge of decarbonizing heavy industrial production itself.
Let me guess, you're going back to the European border tax.
I am, because let's look at the actual downstream effect of that €75 CBAM price. It forces hard-to-abate sectors to act in ways they previously completely refused to. We see this vividly in Eastern Europe, where Holcim Romania and the European agency CENIA have advanced Carbon Hub CBT01.
The carbon capture hub.
Right. It's a massive project meant to capture carbon from cement and lime production. They are setting up to support 2 million tons per year of near-zero cement and 200,000 tons of near-zero lime.
And cement is notoriously one of the hardest sectors to clean up.
Exactly, and for a very specific reason that highlights my point. Just to clarify, electrification alone cannot solve the emissions problem for cement. You can power a cement plant with 100% solar energy, and it will still emit massive amounts of carbon.
Because of the calcination process.
Yes, the chemical process of calcination inherently releases CO2. You take limestone, calcium carbonate, and you heat it up to extract calcium oxide. The byproduct of that reaction is CO2 just stripping off into the atmosphere. You cannot engineer your way around that chemical reality. You have to physically capture the carbon.
Right.
And capturing carbon is incredibly expensive. It yields no better cement. It just adds cost. So it takes the tightening of carbon pricing to force heavy industry to move from like a climate strategy to actual product-linked decarbonization. The physical capture hub in Romania is simply the downstream result of the upstream regulatory cost anchor.
I come at it from a different way. A price penalty alone does not physically build an integrated industrial plant. It just makes the existing dirty process more expensive, which, let's be honest, often just gets passed right on to the consumer. To truly solve the physical challenge, you need regional systems integration. Let me point you to Xinjiang, China, where an enormous, integrated green fuels program recently broke ground.
This is the 500,000-ton project, right?
Yes, and we are not talking about a single-point solution like capturing carbon off one cement kiln. This project is designed for 100,000 tons of green methanol, 300,000 tons of sustainable aviation fuel, and 100,000 tons of green ammonia. What makes this the true engine of decarbonization is the systems thinking. They are combining renewable power-based hydrogen with biomass gasification.
Wait, let me jump in there. When you say biomass gasification, you mean they are taking agricultural waste and essentially cooking it to extract the carbon.
Right. They take local agricultural residue, heat it in a low-oxygen environment so it doesn't just burn up, and it breaks down into a synthetic gas. Then they pair that with hydrogen made from local wind power.
Okay.
This is about connecting feedstock, variable power generation, complex chemical conversion, and end-market logistics into one regional platform. You do not get that level of physical orchestration just by taxing carbon. You get it by mastering the physical complexity of supply chains and process engineering. China is building regional industrial platforms, and that bottom-up physical reality is what actually displaces fossil fuels at scale. But those systems only scale when the macro policy framework creates a protected environment for them to operate. You mentioned the physical constraint of the grid earlier, specifically regarding those AI data centers in Nevada. I suggest that policy frameworks are highly capable of adapting to and, organizing a response to physical stress. How so? I mean, the utility physically doesn't have the power.
Look at the U.S. Department of Energy. They recently published a practical resource guide on exactly how to meet data center electricity demand. They didn't just throw up their hands at the thermodynamics. They laid out clear pathways involving clean energy integration, grid upgrades, aggressive efficiency standards, and demand flexibility. The policy layer is actively managing the physical layer. If the market forces and efficiency incentives are aligned, as the DOE suggests, why can't human ingenuity engineer its way out of the grid constraints?
Because demand flexibility only goes so far.
But think about the price signals. The right price signals on power during peak times will force data centers to become flexible loads. They will shift their compute-heavy AI training tasks to the middle of the night when wind power is abundant and cheap, effectively turning a physical liability into a grid asset.
That's a compelling argument. But have you considered that even the most sophisticated demand flexibility cannot overcome a fundamental lack of physical transport capacity for molecules? Relying on grid efficiency ignores the fact that we have to move massive volumes of physical energy that simply cannot be electrified.
You're talking about pipelines.
Yes, the heavy plumbing. Look at Europe. They recently published a new list of 235 cross-border energy projects. Crucially, that list includes 100 hydrogen and electrolyzer projects and 17 dedicated CO2 network projects. On the surface, if you just read the press release, it reads like bureaucratic plumbing. But in reality, this is the most important long-game decarbonization development we are seeing.
Because it connects the hubs.
Exactly. Europe is explicitly conceding that, molecule infrastructure matters every bit as much as renewable electron generation. You cannot build the green fuels hubs like the one in Shenyang or the carbon capture facilities like the one in Romania unless the physical pipelines exist to transport the hydrogen and the captured CO2 across borders.
Well, sure, you have to move it.
Right, you can capture all the CO2 you want at a cement plant in Romania. But if you don't have a pipe to move it to a geological storage site in the North Sea, your project is dead on arrival. Hydrogen and carbon capture only become investable when that physical transport network and the necessary permitting are already in place. The plumbing dictates the market, not the other way around.
I'm not convinced by that line of reasoning because those European pipes only get built, and more importantly, they only get financed because the market signal demanded them in the first place. Infrastructure capital is notoriously risk-averse. No one is laying billion-dollar cross-border hydrogen pipelines on speculation. They aren't just burying steel in the ground hoping someone eventually uses it.
They are building it because they know the heavy industry needs it.
Yes, but why does heavy industry need it? Because mechanisms like the European Emissions Trading System and CBAM have guaranteed that there will be a robust, high-paying market for low-carbon molecules for the next 50 years. The bureaucratic plumbing you mentioned is literally the physical manifestation of a financial contract.
But the timeline of laying that pipe is what governs the speed of the transition, not the signing of the financial contract. This is where the physical reality bites back. You can sign a 20-year offtake agreement for green ammonia tomorrow morning, but if it takes 7 years to permit the pipeline across 3 different national borders and another 3 years to actually lay the steel, your financial signal is suspended in animation for a decade.
Well, permitting reform is definitely the next great policy frontier.
It has to be, because while we wait for that infrastructure, the power system is being battered by immediate physical demands. Going back to the AI data centers, the utility in Nevada doesn't have 10 years to wait for a permitted hydrogen pipeline. They have hyperscale tech companies demanding gigawatts of baseload power right now. The sheer velocity of digital demand is crashing into the slow, heavy reality of physical infrastructure. The winners in this space will not be the ones with the most elegantly structured carbon accounting software. It will be the heavy civil engineering firms, the utilities, and the project developers who know how to pour concrete, secure grid interconnections, and survive contact with brutal power system constraints.
But we have to distinguish between the short-term noise of immediate grid constraints and the long-term structural shift of the global economy. Serious businesses understand this distinction. They are separating themselves from the noise by utilizing visible cost anchors, like the €75 CBAM price, to make long-term, 20-year capital allocation decisions.
Yeah.
They are using bankable offtakes, like Infinium's deal with American Airlines, to guarantee project revenue before a single shovel hits the dirt. And they are relying on rigorous, verified carbon accounting to ensure that their product carbon intensity is a verifiable asset rather than a liability. The physical build-out you are championing is the necessary labor of the transition, absolutely. But the financial engineering and policy frameworks are the architectural blueprints. You can't lay tracks until you know exactly where the train is being paid to go.
And knowing where the train is supposed to go doesn't matter if you don't own the land, possess the steel, or have the specialized labor to actually lay the tracks. The ultimate winners in this era of decarbonization will be those who master the physical reality. It is about locking in actual physical supply. It's about moving volatile, toxic molecules through newly permitted infrastructure. It is about operating incredibly complex systems like the biomethanol bunkering at Yangshan Port or the integrated green fuels hub in Shenyang. The theoretical phase of the last 20 years allowed companies to make pledges based on projected costs. This new physical phase requires them to deliver actual product under immense infrastructural duress.
Well, it seems we have arrived at a vital point of convergence. While we weigh the drivers differently, the financial blueprint versus the physical tracks, we both fundamentally agree that the theoretical era of decarbonization is entirely over. The luxury of aspirational pathways has expired.
Completely agreed.
Whether we look at it through the lens of strict carbon pricing borders in Europe, forcing the hand of cement makers, or the massive integrated physical fuel hubs in China rewriting supply chains, both the financial signals and the physical pipes must now function together seamlessly. We are operating in an environment where capital structures and civil engineering are completely interdependent.
Exactly. The grace period for pilot projects and glossy sustainability reports is behind us. We are now in the business of heavy industry, massive capital deployment, and raw physical execution. The friction between policy ambitions and infrastructure realities is where the entire future of the energy transition will be decided.
Which brings us back to where we started. Building the clean energy economy requires absolute structural trust in its value. The market gravity must be established before the engineers can start building the dam to capture the flow. As we look at the immense collision between our global clean energy goals and the explosive immediate power demands of the AI era, we must ask ourselves a critical question. Can our physical grid build-out, with all its earthly constraints, ever truly catch up to the frictionless speed of our digital ambition?
It is a profound tension, and honestly, one that every policymaker, utility operator, and industrial firm will have to navigate in the years ahead.
Thank you for a deeply rigorous intellectual exchange. We will leave it to our listeners to consider how policy, infrastructure, and real commercial offtake must combine to power the ongoing global transition. Thank you for joining us on The Debate.